Okay, let's write one or two filters together just so you can kind of see how it works. So main is the program that you'll run to actually use your filters. But let's take a look at some of the filters that come with my framework already. So there's the do nothing filter. Let's take a look. This is sort of like the hello world of filters, but it shows you all the parts that a filter has. So when you create a class that's supposed to change an image, it needs to implement the pixel filter interface. It's worth checking out whenever you see an interface. It's worth checking out what's in the interface. If you hold Control and click or Command click on a Mac, you can see the pixel filter interface. It's got two methods called process image and draw overlay. Process image takes a D image as an input. That's the image that's provided to your filter. It's like the input image that needs filtering. And then it gives a D image as an output. And the output represents whatever the filtered image is. So it's like, this is the actual method that does the filtering. I also give you a draw overlay method in case you want to draw things on top of the display, which is sometimes helpful, if you want to like highlight certain aspects of it. We're not going to talk much about this right now, but you'll see an example in just a second. So back at the do nothing filter, because as the name implies, it does nothing, this is empty. So we take the input D image, we don't change it at all, and then we just return it. So it's not changing the image. But I did put something in draw overlay. So these use the regular processing graphics commands. If you're not familiar with processing, go to processing.org and you can see a list of them. But here I'm setting the fill color to be red. Then I'm going to draw an ellipse. And the ellipse is at the width and height of the original image. So the input here is, this is the drawing window. This is the original image. This is the filtered image if it was different. So if I draw an ellipse at the width and the height, that's like the lower right-hand corner, and it's 10 by 10. And then here I'm going to draw another ellipse at 0, 0, which is the upper left-hand corner. So let's run this and see how it looks. So I'm going to load an image, and all the images are here inside the images folder. And so you might wonder, like, why is nothing happening yet? It's because we haven't loaded the filter. So you can see here in the lower section, I'm giving you a lot of information. So I display where the mouse is. You can see the pixel coordinates are 219, 216. And I tell you the red, green, blue value of the pixel under at that pixel coordinate. So this white is 253, 253, 253, which is pretty close to the whitest white you could get. But Calvin's yellow hair here is 251, 242, 0. Okay, so as it says, press F to load a filter. I'm hitting F, nothing's happening. You got to select the window. Once this window is active and you hit F, now you can load a filter. And just type the name of the class. Do nothing filter. And as you can see, it's pretty much exactly the way it was before, except you can see a little green ellipse here in the upper left-hand corner. It seems like the window isn't large enough to actually see the ellipse in the lower right-hand corner. You can hit S to show and hide the filter, which has no effect right now because this is the do nothing filter. So let's look at another filter. Let's do the fixed threshold filter. So here I get a black and white pixel grid. Well, so here, let's back up. So this one we actually filter. So I take my D image, which is called image, and then you'll see there's a whole bunch of built-in methods for getting pixels. Image dot, so I can get a color pixel grid, I can get a black and white pixel grid, I can get out the color channels separately, so this is like just the blues or just the greens, and we'll do more of this when we get to colors. For now, I want to get out a black and white pixel grid. And then here I have the standard pattern for looping over all rows and columns. And then grid RC is getting out one of the numbers at a particular location in the grid. And remember, these numbers represent grayscale values. So 255 would be white, 0 would be black. So here I'm asking if it's above a medium gray, set it to be white, otherwise set it to be black. So I'm turning a grayscale image into a purely black and white image. And you'll notice that I'm changing the pixel grid that I got out of my input DImage. But the very most important thing to remember is you have to set your DImage again before you return it. You have to set the image using the updated pixel grid because it doesn't update automatically. Okay, let's take a quick look. So I'm going to load from disk, images, let's choose a different image. Oh, yes. So I'm going to load a filter, and the filter is going to be called the, what did I call it? Fixed threshold filter. And so now when I hit S to show the filter, you see that kind of lighter colors have turned pure white and kind of darker colors have turned pure black. And so I'm just pressing S to toggle back and forth. And you'll notice that when I toggle it, the color is showing me like the new updated colors. Okay, let's maybe write a new one together. So I think a good way to write a new one is to just copy the do nothing filter. So I'm going to copy and paste, and let's call this one the add noise filter. Nope, let's call this one the left half filter. That's asking me if I want to add it to Git, and the answer is I do not. Okay, so what I want the left half filter to do, and you should go ahead and add a little comment. I should have been doing this before. Add a little comment at the top that says what this filter does. So returns an image representing only the left half of the original image. Okay, the reason I want to show you this is because I want to show you that you can actually create a completely new pixel grid that's a different size from the original. So let's see. I'm going to get out black and white images, or black and white pixels. So I'm going to make a 2D array of short, which I'll call pixels, and I'll get it from my input image. So image.get black white pixel grid. Except now what I want to do is I only want to copy the left half of the image. So this is the input. So actually maybe I'm going to rename this to be input pixels. And then I'm going to call this output pixels. And my output pixel array is going to be a new array of short. Remember, the number here would be how many rows. This is how many columns. So I want the number of rows, which is like the height, to be the same as the input pixels. But I want the number of columns to be exactly half the number of columns in input pixels. So length divided by 2. Okay, so now I've got that. So let's loop over. So I'm going to loop over all the rows in the output pixels array. And now I'm going to loop over not all of the columns, because remember, columns are like X values. So I only want to loop, well, let's actually loop to the end of the output pixels, because the output pixels are already half the width of the input pixels. And now I just want to copy the pixel values over. So I'm going to have output pixels RC equals input pixels RC. So I take the input, copy to the output. But I'm only going to end up with an image that's the left half because I'm only looping my column up to the largest column in output pixels, and the largest column in output pixels is half as big as the largest column in input pixels. Okay, so then at the very end, I'll need to set pixels, image.setPixels. And you can see set pixels has been overloaded, so you can give it like really whatever pixel array you have, and it will just do the right thing. So I'm gonna reset the pixels with the output pixels, and now I'm gonna return image like this. Draw overlay, I'm just gonna delete that, so we're not drawing any overlay. Okay, let's run it and see. Very nice. Okay, so left half. So as you can see, it's become black and white, and it's also only the left half of the image. Okay, I hope that this was helpful. Good luck on your own filters.